Hello everyone, welcome to the Data Science Mentor session. And in today's session, we are going to be looking at random forests and decision trees. Now, that's what we have been on for a bit. And today we're going to be covering these algorithms. My name is Pablo. I am the host and convener of the Data Science Mentor Program. And the Data Science Mentor Program is meant to teach data science skills, fundamental data science skills, for anyone looking to get into that space. One thing is super important. Data science skills are the fundamentals for building AI skills. And if you miss out on having fundamental data science skills, then you struggle in many ways trying to understand the AI space. And so what we're doing here is pretty fundamental stuff. And today we're going to be teaching an algorithm, two algorithms, but they sort of like come together to do stuff. So we're going to be using a term called an ensemble, right? But that's what we're going to be doing today. I will try as much as I can to make it as simple as I can. This is typically what we do. And then we can now go on to write code and try to bring all these ideas together. Now, the decision tree, so first off, it's important to bring everything we have done together. It is important to bring everything we've done together in a little way. First thing we did was to look at what we've done. We first learned about generative, simple generative classifiers. That's what they're called. First thing we learned was simple generative classifiers. And so if you haven't checked that out, just know that at any point you do, right, we learned about the naive Bayes classes or family of classifiers. Then the next we did was to look at discriminative classifiers. And they're called discriminative, or not discriminative, but discriminative algorithms. And a very good example of a discriminative classifier is the support vector machines, and they draw lines to separate features, or they draw lines to separate classes. So this is a classifier. Then, now, or not then, but now, we are now going to be looking at something called a non-parametric algorithm. Non-parametric algorithm. So I think I should have called this a simple generative algorithm. Or algorithms. This the same way, discriminative algorithms. Now, a non-parametric algorithm. Now, when an algorithm is said to be non-parametric, it means it doesn't have an underlying assumption of any statistical distribution. So it doesn't just think, oh, there's something. If you look at like simple generative algorithms, they typically have initial thoughts about the distribution of their features. If you look at discriminative algorithms, there is also an underlying distribution for their algorithms, which means they're in classes and they can be separated using boundaries. So we're going to look at the non-parametric algorithms. And what we are looking at is basically the random forest and decision trees. So this is what we are going to be looking at today. Now, there are a body of the random forests are an example of something called an ensemble method. So here we look at random forests. And they're called an ensemble method. Now, why would you want to call something an ensemble method? That's because it relies on aggregating the results of, a set of simple estimators. So which means there's something inside of it that does some work. So here relies on aggregations of simpler estimators. We're going to ask what's that simple estimator, right? So it's typically what this random forest is about. Now, I know at this point you're wondering, okay, we've said so many technical stuff, so how do we now piece all this I call it technical verbiage together? So let's look at an intuitive side of it, right? Now, a random forest is, if you think about it, is a gathering of ideas. But before we get to the random forest, we have to break down the random forest in a way that makes it easy for us to understand. So how do we do this? Let me see. All right, so what motivates a random forest? So here, that's the question we're going to ask. What motivates a random forest? What motivates a random forest? Really great question. And the first thing we want to think of when we talk about that is decision trees. And right, so random forest is an example of an ensemble, right? And remember when we say built on they're built on simpler estimators, and its simpler estimator is a decision tree. Now, and so what exactly is this decision tree we're talking about? Now, let us think about just imagine you're playing a game of 20 questions, right? So a game of 20 questions. Now, in this game of 20 questions, what you're supposed to do is you're supposed to ask questions until you have broken down the idea. So if something is thrown to you and you start to ask questions, and you just have 20 questions to ask to get to, after 20 questions, you have to answer the question. You have to have an answer for the question that was given to you at the start. Now, maybe something a concept is shared with you, or you're given a clue of what a concept is, right? And you are supposed to ask multiple, either you're supposed to ask a yes or no question or multiple questions, because once you ask those questions, the idea is you're trying to arrive at a decision. So if you're playing a game of 20 questions, you ask yes/no or multiple choice questions. You ask yes or no or multiple choice questions. Now, why are you doing this? You're doing this so that you piece together, you know, if you ask, this thing we're talking about, is it a male or a female? And you say, oh, it's a male. Okay. And then it goes down to the next. So you just keep halving everything at a point. So you keep doing this until, you know, until you get to a point, right, where you can predict what the question or what it is you're trying to figure out. Now, again, look at here. So these questions make it possible to predict the unknown feature or the unknown target. So you think about that, and while asking these questions, right, you're now having branches. So these questions and answers build, you know, form a branch of yes/no responses. So think of it this way. You say there's somebody in that room, and you're like, who's that? Who's in that room? Right? And then you say, is it a male or a female? And the person say, it's a male. Is the person employed or unemployed? And they say, well, the person is unemployed. Is the person a relative of mine or not? They say, no, the person is not a relative of yours. So now at every question point, right, you are looking to get to the end of a part. So at every question point, you are driving to the end of a part. That's what it's called. And it has a very popular you know, the end of a part has a popular name. It's called a leaf. Now, so you keep asking all these questions because you want to get to the end of the part. So they say somebody is in this room, and the question is, who's that? Right? And then you start to ask questions. Is it male or female? It's male. Now, understand that if it's male, then you're going to ask a question. So it's like you ask the question, you asked a question here and said, the question goes, is the person male or female? And that's the question. Now, this is either yes or no. Now, if it's a yes, now the next question is going to define something. And it's either a yes or a no. So if it's a yes, then the next question is, is the person male or female? Like, if it's yes to a male, right? So if I say it's male, which is a yes, right, then that means we have a different question. Let's say, is the person employed or unemployed? See that? Now, if the question was female and it was no, right? Then the next question is she single or married? See that? And again, this now boils down to a yes/no. Same thing here, right? This is the person male or female. So you now see this again is a question that goes yes/no. Now, this is just what happens until you get to the end of a part. And when you get to the end of the part, you have basically found your answer. Now, think about this, think about this in a situation where this is what you're trying to solve for. This is what you're trying to build on to eventually answer a question. That this is the motivating factor. You know what motivates a random forest? questions. Now, at the now you want to ask yourself, so what is the random forest? So now, since we've talked about a decision tree, so we want to know a random forest, right? Now the question is, what's a random forest? Now a random forest is typically something called the wisdom of the crowd. Now, so the random forest is a coming together of a collection of trees. So a random forest is basically independent decision trees. It's a coming together of a large collection of independent decision trees. Yes, coming together, or what I call it, or let me use a different one. A large collection of independent decision trees. So this is what it is. So it's called the wisdom of the crowd. So if you've got a large collection of it, you have yourself that. So now each forest is trained on a slightly different subset of the original data. So which is it's now a bunch of 20 questions broken down into different ways, right? At the end of the day, it's going to vote. It's going to do like a voting to figure out all the certain decisions that were taken, and it sort of like aggregates it. Right now, for classification, the final answer is almost going to be true or false, or if it's regression, the final answer is the average of all what the trees have come together. Right. So this is what it is. Right. So this is what we are trying to do. And now imagine putting this together in order to create, in order for us to make sense of the different things that hit us in our businesses every day. Right, a customer signs into your web page. Is it a first-time customer? Yes. All right. So then you check, you figure, did the first-time customer do a sign up, or they just getting into the page? Different question. Now remember, on the other end, if it's a first-time customer, no, then it's a return customer. So if it goes no, then it's a return customer. This return customer is a regular customer that comes once in a while. If you say a regular customer, then you keep finding out a bunch of things before you get to what you're looking for. So in today's session, what we're going to do is we are going to visualize some of this data, right? And then just write a few lines of code that sort of says, look, we're going to look at what the decision tree basically looks like. Then we'll now go on to see what the random forest is like. So first thing I'm going to do, I'm going to import the files we're going to be using. So now remember, again, like I always say, we have to think about all we are doing before we start to write code. It makes a lot of sense, always, almost always, right? So first we import pandas as PD. We import NumPy as MP. Then we import matplotlib .pyplots as PLT. Any other thing? So let's put this. So we have this. Now what we're going to do is we're going to create a decision tree. That's what we're going to do. We're going to create a decision tree. So let us create, let's call this creating a decision tree. So now, remember, from if you've been following us, you would not. If you've been following the series, you realize we're going to use an sklearn data set, and we'll pull out one of the data from the sklearn, the scikit-learn data set repository. We're going to pull up what we call blobs, and we're going to make these blobs look in a certain way. Then we are going to now say, imagine if these blobs were data points, right? And you wanted to split up these data points with some level of, maybe, you think about it, what are you going to do with them? With some level, then you're going to say, okay, this is what we're going to do with it. Then at the end of the day, we end up looking at this data point and saying, okay, yeah, this is what we have. So first things first, just in this first series, we are going to look at the data we have. And right after we look at the data we have, and I'll start to tell you, okay, from now, what do we do to break this down? So this, and that will just form the first part of what we're doing, so we don't take it too much at a time. And so we'll just have the data we're going to use. We're going to ensure that this data is sort of different in its nature. And then once the data is different in its nature, we're now, in the next series, we're going to think about, how do we split this data? So to do this, I will import a model class. So I'll import the model class, which is from sklearn dot datasets, and I'll import make blobs, make underscore blobs. I think this works. Yeah. Next, I'm going to, of course, as usual, it's traditional, it's going to be X and Y. Always remember, feature matrix all day, every day. Then we use make blobs. Now with make blobs, we're going to take n underscore samples. We're going to take 300 samples of blobs. We would want our blobs to have maybe different moving parts, right? So we'll just say center, not just different, just like different categories, basically. Then we would put a random state for reproducibility, and any other thing. Okay, we can take cluster. Let's put a cluster std as 1. Any other? Okay, let me bring these guys down. Right. Is there any other thing we're going to put? I think that's it. So we now have X and Y. So we have this data point. Now the next we're going to do is we're going to visualize this data point, and that's where we're going to stop for today. And then I'm going to leave you with something to think about when we come back for our next session. So we now have the data for our decision tree, and we're going to build like a classifier out of it, right? And so this is going to be our first intuition for what we'll do. So we'll have our data first, and then we take it from there. So we have X and Y. So next, I'm going to say plt.scatter. Right, remember at this point, you know that I'm going to take X and I'm going to split it into 2 ways, right? Now, X is going to have like 2 parts, but at the same time, we have the 4 centers, right? So let's go 1, X, yes. Then we're going to, because we're going to use like a color variation with our Y, which means from the 4 centers, it's going to split itself. S equals 50, and then another thing, C map. Should I use autumn? We have been using autumn. We've been using autumn, so let's see if we use it. Let's see if it even works. Because if I want something that will be intuitive, so let me now color this. Oh, look at that. There are 4. this doesn't really give much inspiration. Hold on a bit. Let me go to Matplotlib. The Matplotlib color palettes. So over here, we're going to look at Matplotlib's color palette, and we're going to choose a color palette that I think can work. I need something that can display different numbers, display different colors. We have a list of. So look at that. Select. Okay, hold on. Let me see. There should be some color. I need something that can show me different colors. Yeah. Oh, look at that. I think I need someone like this that can give me like different colors. Something of that nature. I know. Again, I like the way we can look through this. Look at what I was using: autumn, winter, summer. I found something that I find really interesting. Cool, seismic, twilight, accents, prisms. Oh, look at gist underscore rainbow. I think we can use rainbow. Then let's come back here and make for rainbow. Let's see how that looks. Rainbow. That should work. Oh, come on, guys. You see how good this looks? So now this is what we are going to use to break our data points. And now we have like 4 data points. You can see with the different data points in these different places here. Right, you can see we have this guys here, we have this guys here, we have this guys here. And I think that would make it look good. So from here, this is our data for our decision classifier, and this is where we're going to stop for this introduction. Now, in the next introduction, in the next part of our introduction, we're going to visualize how the decision tree splits the data, right? And we'll see how it does that. Now, after we do that, you know, we would now start to think about decision trees, and one of decision trees' biggest problem, which is its ability to overfit, right? And then and just figure out how that will work. Then we'll now go on to random forests, and then I'll see how the random forest typically looks and creates all the different ensembles. Yeah, so that's pretty very simple stuff. And then this now should give us a sense of what we will do if we had a data point, or we had data points in reality. So, but this is where we're going to stop for now. If you have any questions, please feel free to ask at this point. Or you can watch it again. If you watch a recorded session, that's fine. Drop questions in the Telegram channel, right?